Steve Collins again with Desana Partners. We are the suppliers of the DURUS brick rain screen wall assembly. We've talked before, but I wanted to take a few moments to talk about an area or an aspect of the system that we receive a number of questions on. It's probably worth explaining what we do and why we do it and what the benefits are. So let me take a couple of moments to talk about our subframing subgirt system. It is primarily a two-component system, which is to say a series of brackets and rails, and they go together just like this. Excuse me. There are different types of brackets, different types of rails, different types of brackets. This is typically a dead load bracket, goes at the top of the wall. It's 6 inches, sometimes called a double, followed by this bracket, which is a wind load bracket, generally working down below the dead load bracket. Each one of these brackets generally gets a thermal isolator like you see here. Almost every job now requires a thermal isolator. They're pretty standard at this point. So what happens is the contractor will get to the job site and he's going to take a look at this wall. He may or may not have barrier on the wall. He may have, whatever his contract is. He may put this barrier up, he may not. Let's assume that's already there. Contractor gets to the wall and he's got all these parts and pieces and he goes, where does the first one go? Well, here's what we've done. When we receive a purchase order, we go back to you, go back to the architect, and we ask for all of the drawings in CAD format. In which case, we redraw every elevation, every section, every plan, every detail for this system for your building. All of these things are put together accordingly. So the contractor will get his his series of drawings, and for instance, every elevation is drawn as you see here. Perhaps more importantly is the page behind that page is the same elevation, and this is a subgirt page. This tells the contractor where every single vertical goes, every bracket, what type of bracket, how many screws each bracket gets, so that he knows before he gets to the wall where every single bracket goes, how many screws it gets, and where it's located. So let's assume he's getting to the wall now. He knows where he's supposed to go. These are the dead load brackets. They go to the top of the wall. Point of reference, dead load bracket is the heavier bracket. This is the static bracket. This is the gravity bracket. When these go up and the verticals are placed in, these are screwed in with the holes. Not the slots, the holes, because this is static, we don't want it to move. Below, where you see the live load brackets, the verticals are screwed into the slots, because we want these brackets to allow the system to move and accommodate whatever movement we've got from floor to floor and building movement. Excuse me. So the first bracket goes up, usually a couple inches away from the floor line, horizontal spacing every 16 inches. Vertical spacing between the dead load bracket, which is the top bracket, it's the only time you use it, and the next wind load bracket will vary somewhere between 32 inches and 24 inches, depending on the loading, depending on what the engineers come back with based on what they've seen in the building itself. So now you have your dead load and you have your live load brackets. Once these are up, then the contractor comes back with these verticals and he installs them just like you see here. Whoop, whoop, whoop. Hopefully he does a better job than I'm doing. Each one of these things goes in as you see right here. Now I'll show you what we're going into. Each bracket has what we call a tension bar or a helping hand. Each one of these was put into the helping hand piece as you see right here. All right, why do we do that? Excuse me. Once the contractor is here and he's got his first space, his first block, maybe 50, 60 feet, whatever the job gives him, whatever he's comfortable with, he has his brackets up, he knows where those go. He has his verticals installed into the tension bar. And then he comes back to the corner with the laser, and he lasers his entire wall to make sure that it's level and true and plumb. And if it's not, he has the ability to adjust these verticals, just like you saw right here, to adjust them in and out as much as an inch, so that by the time he's finished with his laser, you know that every one of these verticals is straight and true, plumb and level before the first tray, before the first brick goes on. This is what separates us from so many other systems. This is what makes sure that you're getting a brick wall like you expect to get, that is true and plumb. Excuse me. And then the first tray goes up and away we go. The reason I mention this to you is there are systems out there where bricks are adhered to a panel, maybe a piece of wood, a hardboard, a fiberboard, insulation, wood, whatever that might be. And that might be a 4x4, it might be a 4x8 sheet. And those are put directly to the wall. The dilemma with that is you're never too sure what this wall is going to be. We know that by and large most substrates are not terribly level. Probably the worst is what you see in retrofit or recladding the buildings. Maybe the next worst, wood. Wood is always a difficult set of substrate materials to work with. And then you've got parge coats and so on and so forth, and steel framing. It would be great if they were all perfect, but they're not. This gives you the tools to make it work. In the event that you have to put something on like these other systems do, and you see a substrate that's going like this on like a snake, that's how the brick comes out. We don't want that to happen. I bring this up partially because I think it's a cultural issue. What I'm getting at is, for the last 100 years, a general contractor delivers a contract to a mason, and he says, build the wall, make it straight and true and plumb, and he does. And he doesn't worry about what the substrate is, because he's got his lines, his plumb lines, and he's going to build brick on top of brick, and it's going to be a straight flush wall. But if his brick is now being laminated to a panel of some sort, and that panel goes onto an irregular substrate, the mason no longer has the tools to level out the wall. General contractor has been doing this for 100 years. It's your job, Mr. Mason, fix it. He has no method to fix it. That's one of the biggest reasons why we have a two-component system. The other reason, of course, is that in order to meet AAMA standards for range screen systems, you need to be able to come up with an accommodation for insulation, typically, and 2 inches of cavity. 2 inches of free-flowing, unobstructed cavity. And that's what these brackets are for. These brackets that you see here on the wall are 2 inch deep. These are small brackets, of course. We have brackets that, this is a double bracket, it's a little deeper, at 5 inches deep. Brackets we have here that are 6 inches deep. They go all the way up to 10 inches, so that you can, if necessary, accommodate 8 inches of insulation and still get your 2 inches of cavity. That cavity is free flowing, it gives you convection air, it gives you drainage, it gives you a dedicated water management that you don't get with other systems. So the system will give you everything that you need to meet ASTM 90.1. It will meet all of the energy codes, all of the stretch codes that you're seeing now, and even the passive house design codes. That's what a system like this will give you, and still keep your wall level, and still give you drainage, still give you some pressure equalization. That's why we use a two-component system. It not only maximizes the performance of the wall, it allows you to create or to fix any imperfections of the existing wall that you're going over. Let me know if you have any questions. By all means, give us a call. We're here to help. Thank you.
Just ended.